So this represents 0.9. It says, what is the reading speed? So we want to know what is the speed of this reader. Just like if I said Madison's height was in the 90th percentile, how tall is she? If this person is in the 90th percentile of reading, what is their reading speed? If the average reading speed is 125, so all of my reading speeds are on the bottom. So because I'm trying to find a quote-unquote z-score, I'm going to do inverse norm, and I do the area to the left, and then I do mean and standard deviation. So I'm going to do inverse norm. What is my area to the left? 0.9, 0.90, however you want to write it. What is my mean? 125, and my standard deviation? 24. And again, if you get on your test and you're like, holy crap, I can't remember where inverse norm is, I go second catalog. Inverse norm starts with an I, so I find the button that has an I on it, and then all I have to do is scroll down just a little bit until I find inverse norm. Right there. And once I get beside it, I just hit enter. 0.9, 125, and then 24. So that's telling me that if he was in the 90th percentile, his reading score is 155.76. Alright, that was 22. 23 says calculate the standard error of the mean. So 23 says calculate, C-A-C-U-L-A-T-E, the standard error of the mean. What is another name for standard error of the mean? How do we find the standard error of the mean? Good. The standard error of the mean is the same thing, also known as the new standard deviation. The new standard deviation is when you take the old standard deviation and divide it by the square root of the size of the group. So when I say standard error of the mean, that is the same thing, also known as the new standard deviation. When you take that old standard deviation and you divide it by the square root of the size of the group. So the standard error of the mean is the new standard deviation. The standard deviation of the sampling distributions is called the standard error of the mean. So when you're doing sampling, your new standard deviation of the sampling is also called the standard error of the mean. In problems 9 through 12, determine the new mean and new standard deviation. And in the directions it says, 23, calculate the standard error of the mean. So in your directions it's going to say, calculate the standard error of the mean. That's what it's going to say. So it's not going to say find the new mean and find the new standard error. It's going to say give me the standard error of the mean. And you're going to have to know, take the old standard deviation and divide it by the square root of the new standard deviation. So for this one, the new standard deviation is the old standard deviation divided by the square root of the size of the group. So what is my old standard deviation? Divided by the square root of the size of the group. So that's 14/7. And you're going to say, that just looks too easy. It is. You just got to know what they're telling you to do. So this one is going to be the old standard deviation divided by the square root of the size of the group, so it's 10 divided by the square root of 21. This one's going to be a little bit harder. 10 divided by the square root of 21. So that's going to be 2 and a little bit of change. Standard error of the mean. Find the new standard deviation. That is number 23. Number 24, calculate the sample proportion. How do we calculate a sample proportion? What is a p-hat? Calculate the sample proportion. X over N. In a town of 500 households, 220 have a dog. The population proportion of dog owners in this town is. How would I do it? What over what? 220 divided by 500. The sample proportion is X over N. 10 of y'all out of 25 have a job. That would be the sample proportion. Part over whole. So if I do that first one, it's going to be 220 over 500, which is 0.44. That's going to be your P or your p-hat, according to whether we're talking about a population or a sample. X over N. That's number 24. All right, number 25 starts here. Calculate the probability of p-hat. Calculate the probability of p-hat. According to a study done by Wakefield Research, the proportion of Americans who can order a meal in a foreign language is 0.47. Would it be unusual that a survey of 200 Americans, 80 or fewer Americans can order a meal in a foreign language? Let me move this to a different page just so that I can have a little more room. Let me grab my snipping tool. Because I don't want to write over. All right, so what is 0.47 considered to be? Our p-hat. They said that that's our proportion. Okay? So, tell me what I need to do. Besides skip it or eeny, meeny, miny, moe it. I need to bring back up my rules. Remember at the end we did those 3 rules. We did the plain ones, we did the ones with the group, and we did the ones with the P. This is the ones with the P. We've got to do the standard deviation first. Okay. 0.47 is our P. That's our proportion. That's everybody. That's our population proportion. So when I do this, this is going to be our P. That's going to be our middle. That's going to be our 0.47. Okay. Now we need to find our standard deviation. P, 1 minus P over N. So what is my P? 0.47. 1 minus 0.47, what would my N be? 200. That's how many people I surveyed. So when I go to my calculator, I'm going to do 0.47 parentheses 1 minus 0.47. I get my answer. Oops, no I didn't. And then I'm going to take the square root of that answer. So that is my standard deviation. My standard deviation is 0.03529. How am I going to get my p-hat? P-hat. What is my formula for p-hat? X over n. We've already determined what is our n. 200. So how many people out of 200 said in the survey blah, blah, blah? 80. So 80 over 200 in my calculator gives me a p-hat of 0.8. Oh, not 0.8, 0.4. Do my calculator and make sure. 80 over 200 is 0.4. Now, they want 0.4 or fewer. Or fewer. So once I put my 0.4 in there, we need to do or fewer. So what am I going to do in my calculator? Normal CDF. So I'm trying to find that, so I'm going to do normal CDF. Where did it start? Negative 9999. Where did it end? 0.4. What is my mean? 0.47. And then my standard deviation is all of that jazz down there. And I'm going to move it down just so that I can have more room. 0.03529. So I'm going to do second VARS, normal CDF of negative 99999, comma 0.4, comma 0.47, comma 0.03529. And then the last thing, what does it say on the test? On the test, it just says, what number are we on? 25. On the test, it says calculate the probability. So that's all we're going to need. On this, it says calculate it and tell me if it's unusual. Is it unusual? Yes, it is unusual. UNUSUAL, because it's less than 0.0205. But on the test, it just says calculate the probability of p-hat. And because we're calculating the probability, we're finding the shade. Let me let y'all try one of those from start to finish. Let's do this one. Copy. This is still number 25. You just have one on your test, but this will give you one to practice. and the directions. I'm gonna say calculate the probability of the hat. Anybody need a calculator? And I will have those on Wednesday as well. And we also will have scratch paper for you on Wednesday, these formula sheets for you on Wednesday. I will check your calculators for programs. And also, if you get stuck, and your calculator messes up, I will be in here to fix it if you need it. Can't tell you how to do anything, but I can fix a messed up calculator. Find the probability of P hat. Calculate the probability means find the shading. 39% of all adult Americans, that's going to be your P. That's your probability proportion. That's going to be what goes in the middle. That's like your mean, which means we need to know the standard deviation. The standard deviation is going to be the square root of P, 1 minus P over N. So that's going to be 0.39 times 1 minus 0.39 all over N, which was your total sample size, which was 500. So in my calculator, I'm going to do 0.39 parentheses 1 minus 0.39. And then I get my answer. You can do it a lot of different ways. And then I divide it by 500. And then I take the square root of that answer. So this is what I get as my standard deviation. So my standard deviation is 0.021813. Now I get my P hat. My P hat is like my sample proportion. That is like my data point. It's going to be X over N, which is 210 over 500. So in my calculator, I am going to do 210 over 500. That data point is larger than 0.39. So my P hat is 0.42, which is gonna go to the right. And let's see which way we're shading. We are shading or more. So this is what we're trying to find. So I am going to do the inverse norm. I started at 0.42, I ended at 99999, my mean was 0.39, and my standard deviation was 0.021813. And when I plug all that in the calculator, I get 0.08439. Should? Is that what y'all got? No? Let me plug it in then. That's what was on the paper, so let me see. So if I do second bars, inverse norm, 0.42, comma, 99999, comma, 0.39, comma, 0.021813.
It's normal CDF.
I did inverse norm instead of normal CDF. What am I thinking?
Is that supposed to be 0.02181 or?
Adding the extra number changes it.
Yeah,
It
seems
does.
like it.
But the good news is, I don't know why I did inverse norm. Normal CDF and 0.218, 0.21813, I rounded it to there. 21813. I don't know what I was doing. Second bars. No, I'm finding shade. The good news is it's all multiple choice. Yeah, if you would have gone out more places, it would have given you
I had stopped it.
What's the sample size? Can you?
500.
Oh,
Yeah. Yeah, you went out more places,
No, I stopped it.
you go less places.
Yeah,
I usually go at least 4 to 5 places behind.
I did.
And there's
I stopped
probably,
at one.
and there's probably only gonna be one answer that's 0.8. Yeah, but I usually go at least 4 places behind when I do mine. We good? All right, that was 25. Number 26 says, move it down so that I can write. Oops, need to move that. Number 26 says obtain a point estimate for p-hat. Y'all, a point estimate for p-hat means you're doing the same thing. Same thing, x over n. A point estimate for p-hat. S-T-I-M-A-T-E for p-hat. So, a survey of 2306 adult Americans, age blah, 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 417 have donated blood in the past 2 years. Obtain a point estimate of who's donated blood. So give me a proportion of people who's donated blood. How many have donated blood out of the sample? What's your p-hat? 417 out of 2306. So you go to the calculator and you do 417 out of 2306. There's your answer. Out of 1153 workers that were retired, 496 made less than $10,000. obtain a point estimate for the people who made less than $10,000. So how many people made less than $10,000 out of the people I surveyed? 496 out of 1153. I surveyed 1,003, 521 said that they thought it was a luxury to have a TV. So my P-hat would be 521 out of 1,003. That's your point estimate, is just your P-hat. So you really have two problems that are P-hats. That was number 26. 27. Find a critical, let me cut this and put it, I guess I can do it there. CRITICALT value. Find a critical T value. All right, we have two different types. And I'm going to cut these in half. If given degrees of freedom, use degrees of freedom. If given N, then subtract 1 to find degrees of freedom. Okay, we'll show you the difference between both of these. This says 16 degrees of freedom, 20 degrees of freedom. Here it says N equals 16. It doesn't tell you the degrees of freedom. So if they give you the degrees of freedom, use the degrees of freedom. If they give you N, then you need to subtract 1 to find the degrees of freedom. And I'm going to show you on the chart. On your formula sheet, we are going to use table 7. That is the very last page, the front of the last page. Now, it says degrees of freedom, but if you have an N, you're going to do N minus 1 to get your degrees of freedom. So if this is 16, you'll do 16 minus 1. So your degrees of freedom here would be 15. So let's start with number, I guess I can move it here. Let's start with that one right there. We have 20 degrees of freedom, so 20 is our degrees of freedom, and a 90% confidence interval. So 90% confidence interval tells us that in the middle percentage is 90. Now, if you look at this chart shows us the area on the right. So when we're looking at here, we're looking at the area to the right. So that means I need to know this area. I don't need to know the middle part, I need to know this area. So if you look up here, it says the area in the right tail. So if this is 90%, what are these two together? 10. So what is this one? 5. So if this is 0.9, then I did 1 minus 0.9 gave me 0.10, which represents both tails. Then I divided it by 2, so 0.05 is going to be each tail. So that means this is 0.05. So I'm going to have 0.05, and that is what I'm going to use on table 7. I'm going to use 0.05, and I'm going to use 20 degrees of freedom. So if I go to 20 degrees of freedom and come over to 0.05, what is my answer gonna be? 1.725. So my answer is gonna be 1.725. Did everybody get that? All right, if I come down to the next one.